Hello and welcome to the Oxford Centre for Personalised Medicine Flash Interview Series, where we talk to people playing important roles in personalised medicine in one way or another. Today's guest is Professor Andrew Wilkie. Andrew, welcome. Could you tell us a little bit about yourself and your background?
Hello, so I'm a medic by training, and then at a fairly early stage, so this is back in the sort of mid-1980s, I got an interest in clinical genetics, and at that time it was a very small specialty indeed. There was just a handful of consultants, but I was also interested in research, so my training comprised sort of 3 years of really quite sort of hardcore science, which I did in this building here, the Weatherall Institute of Molecular Medicine. And then I did clinical training in clinical genetics. So I became a consultant in clinical genetics in 1993. But at the same time, I moved back to this building to start my own embryonic research group. And so I've been working here ever since in those two roles. And my particular research focus is in children who are born with craniofacial malformations, particularly a condition called craniosynostosis, where one or more of the little gaps called sutures between the skull bones fuses prematurely. And there's a big clinic in Oxford for surgical management of children with craniosynostosis. And so Oxford is a fantastic place to be based, to both provide genetic counselling for families with this condition, but also to conduct research. And basically, when I started here in 1993, apart from a handful of chromosome abnormalities, there wasn't a single child who came to that clinic in whom one could make a specific molecular genetic diagnosis. And now, sort of 28 years later, the figure, the proportion that we can make a diagnosis in is 26%. And it's probably not going to get a lot higher than that, because not all craniosynostosis is caused by faulty genes. So I've been very lucky, actually, to see the entire evolution of this medical process, from being one where, as I said, we could document what was going on, and we could have a guess at diagnoses based on clinical features and recurrence risks. But there was no kind of hard science to back it up, to one where this is now a sort of mature diagnostic process.
Thank you, Andrew. So from your perspective, what does the term personalised medicine mean? And over the course of your career, how has the field of personalised medicine advanced?
All right. Well, I was having a think about this question. And I mean, in a sense, you hope whenever you have an interaction with the doctor that the medicine you're going to have is personalised. So if you have your blood pressure measured, that's personalised medicine. So this is a term that it's a bit of a bandwagon, really, that's been taken up, and it sort of means different things to different people. So I think there are various levels at which you can talk about personalised medicine, but as I say, I think ultimately all medicine is personalised. I mean, thinking about the context in which you're asking this question, I mean, one would be where you have someone who's apparently healthy, but there might be ways that you could identify that person was at higher risk of some particular condition, and that through some process of screening you could identify that higher risk group. Again, there have been processes of screening like that, working at a population level or selected populations for many decades. But again, one particular issue is whether one could use some sort of genetic-based screening to derive more specific personalised information. So that's sort of one definition of personalised medicine. But as I say, from the point of view of a doctor, actually I feel that all medicine is personalised.
That's great. So could you give us an example where, say, personalised medicine in terms of genetic screening has directly benefited the patients that you work with?
So as I said, we've moved from not being able to make genetic diagnoses in any patients this is with craniosynostosis, to making a diagnosis in over a quarter. So a particular example that I would give would be in the past decade, there have been new methods of analysing whole genomes using a process called next generation sequencing. And here in Oxford, we were the first group to ask the question how useful next generation sequencing based diagnosis might be in patients with more complex forms of craniosynostosis where the existing genetic tests had failed to make a diagnosis. And so we conducted this study which we reported in 2017, and so this was on 40 difficult to diagnose patients. And through this NGS process, we made diagnoses in 15 of those 40. It's actually a bit higher now, but if we kind of stick with what was reported in our original publication. So we'd now got a diagnosis in 15 of those. And in fact, in 5 out of those 15, that made an immediate change to the medical management of those individuals or their families. So to provide some examples of that, in one family, there was a little girl with a type of craniosynostosis, and the parents seemed to be unaffected. And usually the recurrence risk that would be given in that situation would be about 1 in 20 of it happening again. But in fact, because of the particular diagnosis we made, we're able to show that in fact, in this family, all daughters would be affected. So that was a very dramatic change in the risk that was being given to a much higher risk, which would have been sort of incorrect. And then in 4 individuals, there were immediate sort of management implications in terms of things like looking for associated progressive cardiac problems into which they could have run if undetected, so echocardiographic screening. Or in another case, it suggested a very specific treatment based on stem cell transplantation. So those are some of the examples where by gaining a specific diagnosis, it actually leads you in quite unexpected directions in terms of what recommendations you make for treatment of the individual or genetic counselling of the family.
Thank you very much. And finally, looking forward to the future, where do you see the field of personalised medicine heading in the next 5 to 10 years? And what do you see and foresee as the potential challenges of implementing personalised medicine in the NHS?
So, I mean, I've been around a long time, and in 1998, so, you know, that's really quite a long time ago, our current Regius Professor of Medicine, John Bell, wrote a very prominent editorial article in the British Medical Journal in which he predicted that genetic testing would be widely used in the clinic within the next 10 years. All right. So we're obviously like sort of well over 2 decades down the line from that, and it's still not the case. And why is that? And the reason is that using genetics in the context of healthy people is very, very different from the context I've been talking about, which was on individuals with a specific congenital disorder. And the type of genetics involved is very different because it's what we call polygenic disease. And so, I mean, what I've witnessed is kind of repeated predictions that this is going to be adopted in the clinic. But in fact, it's a really difficult problem to crack. And I'm somewhat cynical about it, actually. I feel that in terms of the NHS and its future, there are some pretty basic things that need to be sorted out in terms of health inequalities and just simply screening for simple things. I mentioned blood pressure earlier on, simple metabolic things. And actually coming up with genetic-based screens that can improve that is hard. And at the moment, there's a big fad for something called polygenic risk scores. And there's obviously some evidence that they could potentially be of benefit. But what's missing at the moment is really sort of rigorous trials, both of efficacy and cost effectiveness. And there's a slight danger at the moment that these can be sort of adopted as a kind of bandwagon without proper evidence being gathered. So I think that's where we're at the moment. We need to gather more evidence for the value of widespread genetic risk prediction applied to healthy individuals.
Great. Thank you very much for your time, Andrew. It was lovely speaking to you.
Thank you.